Right, so we're going to be looking at probability and statistics. As I said in class, a lot of this packet is sort of some extra stuff, so I'm going to go through and highlight what exactly to focus on in preparation for your final exam. There's actually a lot of probability that we did not cover, so we're just going to stick to what we actually did focus on, what we actually did cover. Of course, we did look at permutations and calculate combinations. So we're going to take a look at those now, and the key here is just going to be the setup and the calculation. So I'm actually going to be using my calculator for these, as that's how we're going to do it. So let's start off with number one. Suppose that 7 people enter a swim meet, assuming that there are no ties. In how many ways could the gold, silver, and bronze medals be awarded? So N is 7, and we are choosing 3, right? Out of 3 total people, we're choosing 3 possibilities. Because order does matter, first, second, third, this is going to be a permutation problem. So in the calculator, we're going to do 7 for N, and then in the math menu, I go over to PRB for probability, choose NPR, 3 for my R value, and so I get 210. So the answer for number 1 is 210. For number 2, we have different committees of 3 people, and we want to know how many can be chosen to work on a special project from a group of 9 people. Here it doesn't matter what the order is. So out of 9 people, we're choosing 3. It's a combination problem. So this is 9, math, combination, 3. And so there we go. The correct answer is 84 possibilities. Right, now for number 3, we have that a coach must choose how to line up his 5 starters from a team of 12 players. How many different ways can the coach choose his starters? So notice here that, assuming this is a basketball team, the order of the players is not important. It's not like the first person picked gets to be the point guard and the second person picked is the shooting guard. It's just the 5 people are the starters, and that's it. So out of 12 people, we are choosing 5. So this is a combination problem. So we do 12, probability, and of course we're choosing 5. So there are 792 combinations for these starters. For number 4, how many different 4-letter passwords can be created for a software access if no letter can be used more than once? So actually here, this isn't so much a permutation combination problem. This is a little bit different. Because what we're doing is, if you have a 4-letter password, for the first letter, there are 26 possibilities. For the second letter, there are 25. For the third, there are 24. And for the third, there are for the fourth, there are 23. So in order to calculate this, this is just going to be 26 times 25 times 24 times 23. And, oh boy. So how many different passwords can be chosen from this 4-letter combination? That's going to be that. And so actually, out of 26 letters, we're choosing 4. Yeah, so that's the setup. So this is a correct answer, 3588800. I'm going to say that this is a no-go. Don't worry about this for the final exam. Your final exam is just going to focus on those quick combination permutation questions like we've been working on. Right, so number 5, there are 25 people who work in an office together. 5 of these are selected to go together to to the same conference in Orlando. How many ways can they choose the team of 5 people to go to the conference? So out of 25 people, we're choosing 5. Order does not matter here, so it's a combination problem. So we're going to do 25 combination of 5. And so here we get 53,130. So that's the correct answer there. For number 6, John couldn't recall the serial number for his expensive bike. Oh, John. He remembered that there were 6 different passwords, none used more than once, but he couldn't remember what the digits were. He decided to write down all of the possible 6-digit passwords. How many different possibilities will he have to create? So there are 6 different digits. He used one no more than once, but he couldn't remember the digits. Right. So the digits are going to be 10. So see, the tricky part here is this is not just a straight permutations question. Actually, no, it is. So out of the 10 numbers, we're picking 6. Order is important because it's a combination, so that's a permutation question. So 10, whoops, that's not what I want. 10, permutation 6. And so we get that 151200. Actually, why don't we try number 4 as a permutation question? That's not right. There are 26 letters in the alphabet. Well, there you go. It's a permutation question for number 4. I still don't like that. That's not a really good question. So, again, don't worry about that for your final exam. For number 7, though, we have how many different 7-card hands can be chosen from a standard 52 deck? Order does not matter, so it's a combination problem. So out of 52, we're choosing 7. So 52, choose 7. Oh boy. So that's 1, 3, 3, 7, 8, 4, 5, 6, 0. The house always wins. Throw some commas in there. 133 million. All right, and then finally, 112 people. All right, I guess my setup's going to be over there. So 112 people bought raffle tickets to enter a random drawing prize for 3 prizes. How many ways can the 3 names be drawn for first prize, second prize, and third prize? The order matters, so it's a permutation question. Out of 112, we are choosing 3. So we do 112. Permutation 3. So here we have 1, 3, 6, 7, 5, 2, 0. So that's another 1.3 million. And that's it for that question. So I'd even say that number 6 as well. Don't worry about that for your final exam. That's kind of, I don't like that. So that's not one for your final exam either. Final exam will be really straightforward. So as long as you can do these, as long as you can do the ones on the quiz we took and the test we took, then you should feel confident about how you will do for the final exam. All right, so the rest of this we don't need our calculator for. So we'll start talking about probability. Now, in the packet, there are a lot of probability questions, so don't worry too much about what's there. I've chosen to go over 2 and 5. All those other probability questions you can ignore. The key here is if you can do the problems that are on your quiz and on your test, then you can do the probability questions on the final exam. But here, we can go through this. These are written out in words as opposed to the notation that I've used before. But it's still the same. We can actually get the notation from this. So a box contains 4 white, 3 yellow, and 1 green ball. 2 balls are drawn, one at a time, without replacement. So we can do a tree diagram to find the probability that 1 white and 1 yellow are drawn. So again, we could do this probability tree as opposed to the tree diagram. And so if I have white, yellow, and green, probability of white, if there are 7, 8 total, probability of white is 4 out of 8, and the probability of yellow is 3 out of 8, and green is 1 out of 8. From these, I can again pick white. I'll keep this in the same order. I can pick white, yellow, or green. White, yellow, or green. White, yellow, or green. And so if I pick white the first time and white the second time, there's a 3 out of 7 probability. For yellow, there is a 3 out of 7 again. And for green, there's a 1 out of 7. For white, there's still 4, but that's a 4 out of 7. For yellow, if there were originally 3, now there's 2, so that's 2 out of 7. And green is going to be a 1 out of 7. White would be 4 out of 7 here. I should give myself more space. 4 out of 7. In fact, why don't I do that? You feel free to skip ahead here because I'm going to reconstruct this. Right, so white, yellow, green. White would be a 4 out of 7 probability. Yellow would be a 3 out of 7 probability. It's not liking this pen. 3 out of 7. And then green would, of course, be 0 out of 7. Okay, so that's my probability tree. So what's the probability that I get 1 white and 1 yellow? So this is actually the probability I get white and yellow. So this could equal the probability of white-yellow plus the probability of yellow-white. Remember, order does not matter. So the probability of white-yellow is 4/8 times 3/7. So that's 4/8 times 3/7. And I can add this to the probability of yellow-white, and that's 3/8 times 4/7. Gonna run out of room there. So this is going to be 12 over 56 plus 12 over 56, which is 24 over 56, which I can reduce. I can reduce somewhat. They both have a common factor here of 8. So this is going to be 3 over 7. So moving on to the next one, I'm going to have what's the probability that the second ball drawn is white given that the first ball is yellow. So this is a probability of the second white given that the first is yellow. And so if the first is yellow, the probability that I get a second white is just simply 4 out of 7, just looking right at that table. Now there is that formula that we use that you could use here again, but it's unnecessary because we can just look right at the tree. And so finally we have C. Find the probability that the first ball drawn is green given that the second ball is yellow. So another conditional probability. So the first ball being green given that the second is yellow. So the probability that the first is green given that the second is yellow. Well, if the second is yellow, then the probability that the first is green is just going to be 1/8 there. We get that right off of the table. That's nice. All right, number 5 here. same deal. Another table. So I'm actually going to make that probability table this time around. I'm going to give myself a lot more space this time. So we got red, green, black, and yellow. So the probability I get red, there are 15 total. So probability I get red is going to be 2 out of 15. Probability I get green is 4 out of 15. Probability I get blue, or sorry, that's black, is 1 out of 15. And probability I get yellow is 8 over 15. Right, so for red, actually for all of these, I could have red, green, blue, yellow, red, green, blue, yellow, red, green. Keep saying blue. I'm so used to blue. It's black. It's a black marble. Right. So I don't need these little branches. I don't know. I'll keep doing them because it's a tree. Trees have branches. Something like that. So red, if the first one I pick is red and the second one is red, there's a 1 in 14 probability. Green's going to be the same at 4 over 14. Oh boy, this is going to take a while, people. So if you are already feeling comfortable about drawing the probability tree, you might just want to skip this part. Right, black is going to be 1 over 14, and yellow is going to be 8 over 14. This pen is really lagging here. Red is going to be the second time around 2 over 14 if my first is green. If my first is green, my second would be 3 over 14 probability. Black would be 1 over 14 probability. And yellow would be 8 over 14 probability. Red would be 2 over 14. If green were picked second, it looks like a 9. But it's not, it's a 4. It's 4 over 14. If I pick 1, the only black marble, there's a 0 out of 14 probability. I'm going to pick that again. And then to pick a yellow as the second would be 8 over 14. Red would be 2 over 14. Green would be 4 over 14. Black would again be 1 over 14. Almost made it all the way. 1 over 14. And then yellow. If I already picked 1 yellow, there's now 7 remaining. So it's 7 over 14. So that's my full probability tree. It's a little bit better than making the full tree diagram. And so if I look here, what is the probability that the second is green and the first one is red? So unlike this previous one in number 2, letter A, probability of white and yellow was probability of white, yellow, plus probability yellow, white. This is just going to be the probability of the second being green and the first being red. So order matters here. So this is second green and first red. So second green is 4 over 14 times 2 over 15. And that's, I mean, you can multiply it whatever. 14 times 15 is 210. So if we get 8 divided by 210, we can just reduce that to 4 over 105. Now, what is known? It is known that the second marble is green. Fantastic. What is the probability that the first one was red? A weird way of wording it. I won't word it like this on your test. Again, I'm going to give you this statistical notation here. So it is known that the second is green. So the probability that the first is red, given that the second is green, is what we're looking for there. So if the second is green, right there, what's the probability that the first is red? second green, first is red. That's just going to be 2 over 15 right from the table. So again, there's that formula, but in terms of what to expect for your final exam, it's those questions that we had on the quiz and on the test. And I know there's some weird ones in this review packet, but these, number 2 and 5, are the main type of math to expect. All right, so here we have a nice little number getting on with the statistics. We want to find the mean. Well, the mean is, this is the average. So this is the sum divided by how many there are. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of those terms. So if I add these up, so 2 plus 18 plus 19 plus 20 plus 22 plus 24 plus 26 plus 27 plus 33 plus 35, and if I divide that by 10, I'm going to get 22.6. The median is the exact middle number. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's an even number. So the median is going to be halfway. So there's going to be 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left. I have to take the average between those two middle numbers. Because there is no one value, I take the mean of the two middle numbers, and I get 23. Now the mode is the most commonly occurring number, and I guess a little bit of a trick question here. There is none. There is no number that occurs the most. The lower quartile is going to be the median of this bottom half, and so that would be 19, while the upper quartile would be 27, and so that would be the median of the upper half. The range is the largest value of 35 minus the smallest value of 2, which is 33. And the interquartile range is just going to be the upper quartile minus the lower quartile, and that's going to be 8. Now, to get the outliers, this is going to be Q3 plus 1.5 times the interquartile range. So anything greater than this, and anything less than Q1 minus 1.5 times the interquartile range. So Q3 is 27. So if I add 1.5 times 8 to this, I believe that's going to be 12. So if I add that together, so 12 plus the 27, that's 39. So are there any values greater than 39? No outliers up there. Q1 is 19, and so if I subtract again that same value of 1.5 times the interquartile range, so that's 19 minus 12, which is 7. Do I have any numbers less than 7? Yes, 2. 2 is an outlier because that is less than 7. That is outside that range. So there is my outlier. So it looks like a daunting formula, but it's actually not that bad. It's just some really straightforward calculations there. All right. So what we're going to have is we're going to have some data, and this is actually going to be helpful for us because if we're figuring out all of these and we're going to find the frequencies and all that, if we look at the stem and leaf plot, that's going to help us put these in order, because if you notice, unfortunately, these are not in order. And so we want to make sure that we put these in order. So if I look here, I'm going to have maybe some 10s and some 1s. So my smallest value is an 8. So I'm going to say that this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what these are all of my values going down the table that are my 10s. And so, 8 is literally 0 10s and 8 1s. So I can put that into my table as 0, 8. So I get 0, 8. Actually, I believe that's my smallest value. Yes, so 0, 8. Now I do want to try and keep this as even as possible, so as evenly spaced, as nice and lined as possible. But obviously, sometimes that doesn't work the best. Okay, so the next up, we want to have the next largest value, and it looks like that's going to be 10. So going through this list, going through the numbers, yes, I think that 10 is the next smallest number, so that's 1, 0. Are there any 20s? Yes, there's 120, so that would be the smallest value there. The next smallest value looks like that's going to be 29, so 29. 30, I have my smallest value of just simple 30, so that's 30. I have a 31. That's the next smallest value, or next largest value, I should say. So 31. And then I have a 34, but I have a 33 first. So 33, 34. There is a 36. I think that's it for the 30s. Ooh, there was one 36. There's two 36s. There's two 36s. But yeah, I think that's it for the 30s. Oh, there's a 38. Okay. Next on to the 40s. So if I look at the 40s, there's 140 and 146. Oh, before that there's a 42. And there's a 46. And that looks to be it for the 40s. There is a 53. There's a 55. And I saw a 56 there. And that looks good. Next up I see a 60. So there's a 60. There is a 63. So there's a 60, there's a 63, and a 67. For the 70s, there's 70. I just saw 71. Yep. Oh, I just saw 64. So we got to fit in that 64. Try to make our 4s not look like 9s. Okay. And so the 70s, we look good. So for the 80s, we have two 89s there. And I see that there's a 91 and a 92. And I have 1, 2, 3 100s. And I just saw that I missed an 80. Wow, this is a miserable experience. That's why statistics uses a lot of software. Right, so we have these values there. And I missed a 60. Did I cross that out? Please tell me that's the one I crossed out. Well, let's just count to make sure. So I should have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Down here I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 31. Nope. So I did in fact miss that 60. So these numbers can actually slide down. And I'm going to have two 60s in there. Excellent. So what we want to do is we have this stem and leaf diagram, so we can use this to help us make a histogram next. And actually even a stem and leaf diagram, or actually a box and whisker diagram. So for the box and whisker, which we can say is next, we would need to find the lowest value, the highest value, the quartiles, and the median. So first off, I'm going to find the median, which is going to be the middle value. So I know that, again, that there are 32 values here. So the median is going to have 16 to the left and 16 to the right. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So right in there. And just to check, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to the right. So this is between 55 and 56. So the median is going to be 55 plus 56 divided by 2. It's the mean between there. And that is 55.5. Now there's 16 in the bottom half here. So Q1 is going to be 8n. So 1, 2, 3, 4, 5, 6, 7, 8. Make sure that I make these differently. And so that's between 34 and 36. So the average of 34 and 36 is going to be 35. And so Q3 would be 8n. So 1, 2, 3, 4, 5, 6, 7, 8. So what's halfway between 71 and 80? So 71 plus 80, 80 divided by 2. That's going to give me the median. So 71 plus 80 divided by 2. And that's going to be 75.5. So the highest value is 100 and the lowest value is 8. So if I make this box and whisker plot, I'm actually going to have a lot of values in here. So what I'm actually going to do is I'm going to just make these values scale by 10. So if that's 0 and this is 100, then I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, this will be 100. And what this is going to do is give me a nice scale here. And so when I make my box and whisker plot, I'm going to have my value, my smallest value is going to be 8. So if this is 10, 8 is about there. My largest value is 100, which is about there. And these values for the median is going to be 55.5, so 10, 20, 30, 40, 50. 55 is going to be halfway to 60, so about there. And then the Q1, so the lower quartile, is 35, so again we got 10, 20, 30, so about 35. And Q3, the upper quartile, is going to be 75. So if this is 60, that's 70, so 75.5. Maybe about there. 80, 90, 100. Again, when we do this, it's not going to be as accurate when we're doing a different scale. So there's going to be some differences and some estimation going on, but that's okay. We don't mind that too much. If we want it to be really accurate, we would use statistical software, which for a pre-calculus class is a little bit unnecessary. So just familiarizing yourself with the box and whisker plot, that's what we want to do there. Okay, so now let's focus on making this into a histogram. And so a histogram, we need to find some bins. So here between 100 and 8, this has an overall range of 92. So I don't know, I can make my bin size, my range here, 10. So I can go what's between, let's say, we can go 0 to 9, then 10 to 19, and 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. But then we have that 100 in there, don't we? So then we can do 100 to 109. We can give ourselves another interval there. So maybe if I put this work off to the side there. Sure. Okay. 100 to 109. Now, there is no set rule for these intervals. If you wanted to start with 1 and do 1 to 10, and then 11 to 20 or whatever, that probably would have been better, but it's not that big of a deal. As long as you're not doing something that's has 20 bins or something that is so spread out, then that's fine. This is fine. So what are the values between 0 and 9? Well, if we had it in this list, this would be a mess. But by making a stem and leaf plot, it actually got a little bit better. So the frequency for stem and leaf here, for anything between 0 and 9 is 1. We just have a value of 8. From 10 to 19, anything in the teens, again, we just have 1, and that's 10. In the 20s, we have 2. In the 30s, we have 1, 2, 3, 4, 5, 6, 7. That's 7 values in the 30s. In the 40s, we have 3 values, as we do in the 50s. In the 60s, we have 5 values. In the 70s, we have 2 values. In the 80s, we have 3 values. 90s, we have 2. And in the hundreds, we have 3. So this is my frequency. Now the cumulative frequency is going to be the running total of these. So the last value should be 32. So 1 plus itself, or just 1 is starting cumulative frequency. And then 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 7 is 11. 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 5 is 22. 22 plus 2 is 24. 24 plus 3 is 27. 27 plus 2 is 29. And yep, 29 plus 3 is 32. So for the relative frequency, we want to take these fractions and have them over 32. So how much it is over the entire total. So for this, we want decimals. We write them as fractions, but we calculate them as decimals. So this is going to be 1 over 32 for the frequency, and that's going to be 0.03, as is 1. For 2 over 32, 2 30-seconds, that's going to be 0.06, which is double that. For 7 over 32, that's going to be 0.29. For 3 over 32, 3 30-seconds, that's going to be 0.09. So we got another 3 there. And actually, I can hit up all my values that I already know. So 3s, there's a lot of 3s here. I already know that 2 is 0.06. So I just need to calculate 5 divided by 32. And so that's going to be 0.16. Now, because I've rounded here, if I add these up, they may not equal 1. But if I add up all the fractions, they'll equal 32 over 32, which is 1. Now, the relative cumulative frequency, here I'm going to add up these frequencies. So 0.03, 0.06, 0.12. This will be 0.41, I believe, because 12 plus 29 is 41. Yep. This will be 0.50. This will be 0.59. This will be 0.75. This will be 0.81. This will be 0.90. 0.96. Unfortunately, we didn't get as accurate as we should have because we've rounded by quite a bit, so we're off by a few here. But that's, at the end of the day, that's okay. Again, because we round it so much. But that's how you get this. So if we want to make a histogram of this data, whoops, what we could actually do is I'm just going to copy. So we did the box and whisker plot. If we want to do the histogram, I have these, and so what I would need to do now is to make my axes. So I have these 10 bins. So on my x-axis, I of course have 0, and then I have 10. This will be 20, 30, 40, 50, 60, 70, 80, 90, 100. Label sum. Obviously, you guys with your handwriting is probably a little bit better. So anyway, this down here on the x-axis, on the y-axis, we're going to have frequency, which is going to go up to 7. So 1, 2, 3, 4, 5, 6, 7. And down here on the x-axis, we're going to have, these are actually graduation rates. And so what we're going to do is we are going to make a nice little histogram here. So I'm going to do a separate line here to separate these to put a border, but we don't need this. So anyway, between 0 and 9, we're going to have 1, and it's going to look like I'm ending this on 10, but remember, that's just where the next interval starts, and that's actually also at 1. So, not great. This computer is not the best for this. Between the next interval, we want to go between what's in the 20s, and that's going to be 2. Frequency of 2. Next frequency between 30 and 40 has a frequency of 7, and so that's all the way up there. The next interval is for 3, so that's 1, 2, 3. For anything in the 50s, again, is going to be 3. Anything in the 60s is going to be 5, so if that's 3, that's 4, that's 5. In the 70s, we're back down to 2. In the 80s, we have 3. And in the 90s, we have 2. And I actually should have had another value here for the 100s, and that's going to be 3. So I can actually amend my x-axis there and say that's 110. And also I should have some values here, so I know that these are 1s and not hundreds or anything like that. So So that's how we make a histogram for that. So that took long enough. Oh God, let's do this again, actually. These are the graduation rates for Division 1. Are these the same numbers, though? They're not. Oh, sorry. These are all athletes. These are basketball tournament teams. These are all athletes. Great. So we're looking at the spread here. So if I look here, the maximum number is 90. The lowest value, it looks like it is 50. So if we calculate this again, this is going to be 5, 6, 7, 8, 9. And so, all right, let's do it. Let's do the 50s. So 50s. So we got 6 and 3. So that's 3 and 6. The 60s, that's going to be 64, 69, 69. Looks like we got that. 64, 69, 69. For the 70s, we got, it's just a simple 70. We got 171, 2 72s. Do we have any 74s? We got a, no, we got a 75, 2 75s. I missed a 57. Go back and get that. 75s. No other 70s, but I do have 1, 2, 3 79s. Whoop, there's a 78. So I got a 78 and then 3 79s. I did actually miss a 67, so I have to go back and fix that. So I still have my 64, but I did have a 67 in there. So I got my 60s now, my 70s. There is a 76. I did miss that. Shoot. $60. 76. Okay. On to the 80s. 80s, 80s, 80s. Lowest 80 value looks like it's 81. Nope, it's 80. Then followed by 81. Then I got an 82. I don't see any other 82s, but I see 1, 2 83s. There's an 85. 85, 86, 89, so 2 89s, cool, 2 89s, and then I get 90, so I get a, oh, I missed another 86, yeah, shoot. For the 90s, finally, 94, 96, 96, and 97. Cool. Ooh, you know what? I did forget all the way back here for the stem and leaf plot, I forgot a key. So for the key, I would need to say that 0, 8 is equal to 8. And for over here, I could say that 5, 3 is equal to 53. Right, so last time we did this, I think we found the median first, so let's just double check to make sure I have all these values. Fingers crossed. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So same 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Thank you. So 32 is going to have 16. It's going to have 16 on the left and the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So for the median, we're going to have the average of 79 and 79, which is just about 79. For the lower quartile, because there's 16 in this bottom half, we're going to have 8 to the left, 8 to the right, so I'm going to count in 8. So there's 3, 6, 7, 8. So there's my little marker. So I'm going to have between 70 and 71, and that's going to be 70.5. That's Q1. And then Q3 will be, of course, 8 in. So 1, 2, 3, 4, 5, 6, 7, 8. So halfway between 85 and 86. And that's going to be equal to 85.5. Awesome. So when I make my stem and leaf plot, actually the smallest value is 50. The largest value is 97. So, you know, interval of 5 might actually be good here. So if I start with 50 and I do 5, that's 60, 70, 80, 90, 100. The smallest value is going to be a 53, which I guess actually is more accurately, if this is 55, it's about there. And the largest value is a 97, so about there. Right, so we're looking at our quartiles and our median. So our median is at 79, so just about there. And so for the other values, for quartile 1, it's just a little bit above 70, 70.5. And for quartile 3, that's going to be 85.5, so just a little bit above 85.5. And so, whoops, we combine these, give these a nice little roof and a little floor. And of course extend out our whiskers. Oof, that's hideous. All right, there we go. That's our box and whisker plot. So pretty nice plot. Now, when we're making a histogram, we want to find out some frequency. So we got to make bins, and so we want to assign values and groups. So if my range is, you know, about 50. There's a lot in here, so I don't know, maybe I want to do a you know, interval of 5, and I can start with because I should start with 53. Yeah, so I'll start with 53 and I'll go to 57. So actually going down, I'm going to count by 5s because 53, 54, 55, 56, 57, that has values of 5. So if I just keep adding 5 going down, so it's going to be 63, 68, 73, 78, 83, 88, 93, and ooh, actually, yeah, to 97. That's going to end perfectly. So these will end just before, so 62, 67. This will be 72, 77, 82, 87, and 92. All right, so the frequency, how many are between 53 and 57? Well, there are 3. Between 58 and 62, actually 0. But between 63 and 67, inclusive, we have 2. 68 to 72, I got 1, 2, 3, 4, 5, 6. From 73 to 77, I have 1, 2, 3. From 78 to 82, I have 1, 2, 3, 4, 5, 6, 7. 83 to 87 is 1, 2, 3, 4, 5. From 88 to 92 is going to be 1, 2, so that's just 2. And then 93 to 97, that's 1, 2, 3, 4. And again, that should all out to 32. So cumulative frequency, I'm going to add up. So 3 plus 0 is 3. 3 plus 2 is 5. 5 plus 6 is 11. 11 plus 3 is 14. 14 plus 7 is 21. 21 plus 5 is 26. 26 plus 2 is 28. 28 plus 4 is 32. And that's the total that I want. So the relative frequency is, again, going to be how much it is in comparison to the total. So 3 out of 32 is going to be 0.09. 0 is just going to be 0. 2 out of 32, that's going to be 0.06. 6 out of 32, that should be double, so it's going to be 0.18, but actually if we round it, it's 19. We get another 3, so that's 0.09. 7 divided by 32 is 0.22. 5 divided by 32 is going to be 0.16. 2 divided by 32 is going to be 0.06. And so 4 divided by 32 is going to be 0.13 when I round it all up. Now again, I round it quite a bit, so this should add to 1. Probably not going to do so. So here's 0.09, 0.09. This right here, this is going to be 0.15. This will be 0.34, 0.43. I have the hardest time making my 4s not look like 9s. 0.65, 0.81, 0.87. Oh, would you look at that? 1.0. Perfect. Absolutely perfect. Got lucky on that one. Probably made an addition mistake on the other one. But anyway, we can make our histogram now based off of these groups, these intervals. I don't need to worry too much about the other values there, just calculating them. So here I want to make sure that I have my scale appropriate. So I'm going to start with 53, so I'm going to do my little buzz there. So this is going to be 53. Then don't forget, these are all at the starting values. So 58, 63, 68, 73, 78, 83, 88. That's why we measure once, cut twice. Just make this histogram over here, extend this. 88, that's a 93, and we'll end at 98. And again, down here, this is graduation rates. And on the y-axis, we're going to have just the frequency. And the frequency is going to go up to a maximum of 7. So 1, 2, 3, 4, 5, 6, 7. Okay, and so now I can make my bins. So I still have my fancy, I still have my fancy boxes there. So if I'm looking here, between 53 and 57, there's going to be a frequency of 3. Between 58 and 62, I have a frequency of 0, so I can just leave that as 0. 63 to 68, I have a frequency of 2. The next interval has a frequency of 6. The next interval, 73 to 77, has a frequency of 3. Between 78 and 82 is going to be 7. So just one more than this other one. Between 83 and 88 is going to be 5. Between 88 and 93, that has an interval of 2. 93 and 97 is going to be 4. And so that's my completed histogram. So for your final exam, know how to make a histogram, box and whisker plot, stem and leaf plot, find these values, and that's it for statistics. Make sure you do still remember permutations and combinations, and also just being able to find simple probabilities.